I already told you that from this lecture sheet or this chapter, there might be more than one question. Okay, might be one and a half. So today we'll talk about the mode circle. So mode circle mean actually in this chapter, the whole chapter we talk about the plane space element. That you have an object that has load only in XY plane. There is no load in along Z direction. So this kind of object with this type of load, we can solve it by algebraic method, by equations that we show already. But in algebraic equation, what is the problem? You have to memorize all the formula. Then you have to figure out, right? This is one thing. Other thing, say you are working for a submarine company. They build the submarine. Now you have a assignment in particular section you are analyzing, right? With say algebraic equation. And you are making a report and give it to your supervisor or your boss or lead engineer or project engineer, whatever your immediate boss. So if you use the algebraic equation, then he has to look, your report might be 4 or 5 pages to look at it, what is the value of sigma 1, sigma 2, tau 1, tau 2, and what is the angle, right? This is one thing. At least might be the simple one, at least it might be 4 pages or 3 pages. But if you use the graphical method, that means mode circle method, then everything you can put in only in a circle. If your boss look to the circle, he'll be immediately realize that what's going on. How much the sigma 1, how much the sigma 2, what is the maximum stress, and what is the angle. Okay, this is one benefit. Other benefit, you don't have to memorize the formula, and it's very simple to draw. So since it is a circle, so what do we need? We need to, what is the circle? Actually, it is a graph, curve. Instead of straight line, it is a circle continuously changing the slope. So if you draw a circle, you need a center of the circle. Without center, you cannot draw it. Then you need a radius of the circle. If you know those things, you can draw it anywhere. Now, if you give your younger brother, hey, here is the circle as radius, here is the center, draw a circle. He can draw it immediately. But in engineering application, you need to figure out the axis. What is the axis of the circle? Because it is a graph, so you should have x-axis and y-axis. So in our plane stress element, we will talk about all the stresses, right? So along x-axis, we will have x-axis and y-axis. So along x-axis, we'll put the, you look in the plane stress element, we have only two type of stress, shear stress and normal stress. So along x-axis, we will put sigma. If sigma negative, then it will go negative x-axis. Okay, if positive, it will go positive x-axis. Positive means tension. This is one thing. And along y-axis, we will put shear stress along y-axis. So if you know the center of the circle, or if you have a formula of the center of the circle, if you have the radius, and you know along x-axis is the sigma, y-axis shear stress, you can easily draw a circle. And from that circle, we will figure out the value of sigma, says, I just write down sigma 1, sigma 2, then we will figure out the tau 1, tau 2, and also we'll figure out phi p. Phi p means principal plane angle. Then we will figure out phi s. Everything will figure out. And very simple way we can figure out. So now in algebraic method, what we did, we use some sign convention like positive stress is the tension, negative stress is the compression. That one we use right over here, same thing. But shear stress in algebraic method, if it is rotated anti-clockwise, then we say this is positive in the algebraic method. But in Mohr circle, if shear stress rotate clockwise, then we'll call it positive. That's little bit different right over here. Okay. So if shear stress clockwise, then it is positive. So let's review the sign convention, that what are sign we will use. Okay, right over here. So as I told you, you need to have a center of the circle. So center of the circle, sigma x plus sigma y divided by 2. That means what is this one actually? That value actually the average stress. You see, sigma x plus sigma y divided by 2. And you take algebraic summation. If sigma y, say this one is coming, for example, this one coming 100, and sigma y, just for example, opposite, it coming 60. Then what will be center of the location? So 100 algebraic summation. So 100 minus 60 divided by 2, comma 0. This is the giving you the coordinate of the circle. So what I told you that we should have two axes, y-axis, x-axis. So along x-axis, we will have sigma. So this direction sigma will be positive, and along x-axis, negative x-axis sigma will be negative. This is my origin. And vertical axis, we will draw the tau. Now, who is tau? There is two tau. Sigma, if is compression, then negative. Then we know. If it's tension, positive. So we don't have any confusion. But in algebraic method, what we did? If it is rotated anti-clockwise, then it was positive. But in Mohr circle, if it is rotated clockwise, then it is positive. So that means positive tau will be go upward direction. If tau is negative, then it will go or negative or rotate anti-clockwise. This anti-clockwise, then tau negative. And this tau is clockwise. That's why this is positive. So you see there is a two axis. So in this axis, where will be center of the circle? Sigma x plus sigma y divided by 2, comma. So you see, obviously, the center of the circle will be on the x-axis. Because y coordinate 0, easily you can figure out. Now, what you need? You need to have the center of the circle. I'm sorry, radius of the circle. What is the radius? This is the radius of the circle. R equal to sigma x plus sigma y by 2 whole square plus tau xy whole square. Now, I just show you the formula, that this formula, right over here, this actually part of algebraic equation. This one also part of algebraic equation. So let's just show you the formula that what we have. You see right over here, this portion, right over here, this portion actually the radius of the circle. And this is actually location of the center of the circle. So and is tau. That means radius of this is tau. So radius of the circle is actually coming tau. So what I like to say, that if you able to figure out the center of the circle, and if you know the radius of the circle, then you can easily figure out the, where I draw it, right over here. You can easily figure out the, easily you can draw the circle. Okay. Now, so these two sign convention, you have to memorize. That if tau rotate clockwise positive, anti-clockwise negative. Now, so these two formula you have to memorize. Now, how you will draw the circle? One thing you need to remember, you always think only these 2 points, this point and this point. These 2 points you have to think, point B and point A. Okay, could you just hold on 1 second? Just. Okay. So if you know the center and the radius, you can easily draw the circle. Now, when you have the plane stress element, where you look at it, you see point B and this point is same, right? And point A and this point is same. So you will always look only at point A and B. So if you like to draw more circle, I have to draw a graph, right? So you figure out coordinate of point A. What will be the coordinate of point A? So point A, if you look, what is the x coordinate of coordinate point A? Point A, we have x coordinate is the sigma, normal stress. Over here, sigma x, and it is tension. So we can say positive sigma x, comma y-axis, y coordinate. What is the y coordinate? Is the tau, right over here, shear stress is tau. But this tau is rotating anti-clockwise at point A. So this will be negative. Then y minus tau x y, right? Similarly, you look for now B. You look for point B. Point B, we have sigma y, comma. What is the tau over here? Point B. This tau rotating clockwise, right over here, this tau. I'm showing with my mouse. So then right over here, you need to write down positive tau x, y. This is 2 coordinate. Okay. So if you know the center, or if you able to figure out this coordinate without knowing the location of the center and location of the radius, you can draw the more circle and you can figure out everything. Only you need to make the graph paper along x-axis, y-axis, and put the point A and B. Then I'll show you that how we can draw the more circle and figure out the sigma 1, sigma 2. You remember what is the sigma 1? Principal stress, and that sigma 1 at sigma 1 and sigma 2, there is no tau. Tau 1, tau 2 is 0. That we need to figure out, right? And at shear stress, we know that tau 1 and tau 2 maximum. Both are equal sign, yeah, equal value, but opposite sign. And right over here, your sigma equal to sigma average. And you will see nicely, we can figure out from the graph. So let's see. This is the fundamental, right over here. We just draw a more circle. This is our plane stress element. So at first, let me draw the point A. Okay, so point A, what is my coordinate? Sigma, right? I just take sigma, sig x, comma, right over here, my tau is negative because it's rotating anti-clockwise. So minus tau x, y. Okay. And now this point I'll put in the graph paper. How we can do it? At first, I have to make a graph paper, right? So this picture I took from the book. So what I'll do, I'll use a red color and I'll draw the, first I draw the axis. So anywhere you just make a straight line. I'm just putting on of it, straight line. And depending on situation, you can put y-axis. You can put y-axis right over here or left side. So better to put left side. Okay, so I am putting, this is my y-axis. So obviously, this point will be 0. So I am saying this is my 0 point. So along then you mention your axis. So this is my sigma, and you just say that I put right side sigma positive value E. Okay. That means if sigma is tension, that will go right. And right over here, sigma negative. Because, but in our right over here, all are tension, but still you need to show it. Now tau. Over here is showing tau clockwise positive. So you put tau, so upward obviously positive. Now which one positive? Clockwise or anti-clockwise? In the Mohr circle, we know clockwise positive. Normally I put this way. But what I'm meaning, if tau is already clockwise, I'll go upward. And this one is negative tau. If tau rotate anti-clockwise. So this is my x-axis, y-axis, I fix it. And all the line you forget about, or forget about the circle. So what I'll do, at first, I have two options. I can put the my center of the circle. I can use the radius, then I can draw the circle. But instead, I'll use the other policy. I like to identify the point A in the graph. So point A, this is sigma x. That means from the origin, I have to, can I go left side? No, because this is positive value. So I have to go right side. Say I came in right over here. This mass is my sigma x, right? Then what is the y coordinate? Minus tau. So I have to go obviously downward because downward is negative. So downward, I come right over here. This is my point A. So I'm saying, say this point is the ace. Okay. Now anyone can tell me what will be the value of ace E? Ace E equal to how much? Anyone? Not AC, I'm making mistake. O is equal to how much? O is equal to is the sigma x, because first we plot the sigma x, we run from origin to ace, then we go down. So O is the sigma x, right? That means length of OH is equal to sigma x, and length of ACA will be equal to tau xy. This is equal to tau xy. Okay, now I look for this point. This is my B point. So what is the B point? At point B, my sigma y, normal stress. So I put sigma y, comma. Look in the shear stress. It rotating clockwise, so it's positive. So tau xy. Now this point I'll put in the graph paper. And right over here, we are thinking this is all the number. I'm sorry, there's no number, right? So I'm just thinking that value of sigma x is greater than sigma y. Now I'll put the point B in the graph paper. So if sigma x, sigma y is 30, from the 0 you go 30 unit. If it is 10, you go 10 unit. If sigma y is negative, you go left side. So this over here, sigma y is positive. So I can go anywhere, but I just came right over here. This is my sigma y. If this is g, then what is OG? Then value of OG will be equal to sigma y, right? This equal to sigma y. Now, so I like to plot point B. So from origin, I came in point G. Then I have to look for y coordinate. But my y coordinate tau xy, so this is positive value. And you see for both point, tau xy is same. The sign is different. So from here, you'll go upward. This is the point B. So you got point A, you got point B, right? So from point A, I make a straight line. 1 second, I erase this one. Right from here, I came in right over here. Okay. Then point B, I make it just a line. Now you see BG will be how much? Equal to tau x. So I can write down that BG equal to tau xy. So BG and AH both are same. So how much distance? Distance from O to H will be how OH will be how much? Sigma x. That they are showing right over here. This is sigma x. And what is the OG? OG will be equal to sigma y. This is just showing over here. OG equal to sigma y. So you have the point B and point H, right? Now you join these two lines. And they are intersecting with x-axis at point C. At point C. So this point C is the center of the circle. Now you use your tool from geometry box. Then use the divider. You just make a circle. So I already draw it, so I draw it right over here. Just 1 second. Okay, so sorry. So what we'll do? We will make the circle. You make the circle. Obviously, circles will be more nicer when you draw out with that tool. Okay, now we see from point C, when you take your compass in point B or point A, then just make a circle. So obviously C will be center and circle will go through point A and B. Now what do you see? What is the length BC? Length BC, radius of the circle. Length AC, radius of the circle. Okay. And length CE, how much? CE, radius of the circle. Length CD, also radius of circle. Now easily I can figure out the value of a radius. How you can figure out easily? Just 1 second. Let me erase some of those lines. Then we see how we can figure out. If I do triangle, I use this triangle BGC, this triangle, perpendicular triangle, right? And this triangle BG equal to how much? BG equal to tau xy. You see BG, so I just write down that BG equal to tau xy. So if I know CG, this distance, then I can easily figure out this one by square formula. So how I can get the CG value? So let's see. I know the value of OC. What is OC? Center of the circle. And center of the circle, that means distance from here to here. We know sigma x plus sigma y by 2. So you see, and what is the OG? If I write down OG, this equal to how much? OG. We already write down over here. OG equal to sigma y. That means distance between this line and this line. Over here is showing this is sigma y. So I'm saying this is sigma y. Now, what is the I need this distance. So, but I know the OC. OC I know. What is the OC? OC is the location of the center. So sigma x plus sigma y divided by 2. This is my OC. So how I'll get CG? If I erase this line, all this line, I can figure out the CG easily. If you just carefully CG, this CG equal to C OC. I can say OC. That means distance from here to here minus OG. That means this much distance minus OG. Now OC equal to how much? OC equal to sigma x plus sigma y divided by 2 minus OG how much? Sigma y. OG minus sigma y. If you simplify that one, if you simplify, you will get sigma x minus sigma y divided by 2. So this is my OG. So you see, we got BG. Now let me erase all of this line. Right. So I got the CG. My CG value is right over here. That CG equal to sigma x minus sigma y divided by 2. Now, how much this one? Tau xy. How much this one? This value. So what will be this value? Equal to this one. Sigma x minus sigma y whole square divided by 2 whole square plus tau x whole square. And you see, this one is coming like algebraic formula that inside the square root. Now, you got the point B, you got the point A, you draw the circle. Then what need to do? You draw a vertical line through the center of the circle. Then you get this intersection point, right? Now tell me, how much will be this distance? Distance from here to here, radius of the circle. From here to here, also radius of the circle. And this point is the E and G point is the maximum tau. Because if we move left side of point F, your tau gradually decreasing. Tau decreasing. When we coming point D, tau becomes 0. And you see sigma coming maximum. From the left side, you going down, your tau decreasing, then you got the minimum sigma. So that means coordinate of point E is the maximum tau. So what is the coordinate of point E? F. So point F, you need x coordinate, that means sigma. And you see coordinate of point C and x coordinate, C and F will be same. So there will be x coordinate sigma x plus sigma y divided by 2. What is the tau? Tau will be radius of the circle. That means this value. So I just say this is tau. And I am putting positive because upward direction tau is positive. And what will coordinate of point G? Point G will be sigma x coordinate will be same as F. So sigma y divided by 2 comma minus r. So this will be G coordinate. So if you figure out the maximum radius, that is the maximum shear. And what will be the stress at that point? Normal stress, sigma average. That is just showing there right over here. Right over. Okay. So we got the top. Now who will got the now principal stress? You see that in the principal stress, tau 0. Where will be tau 0? Obviously in the x-axis tau. So coordinate of point D, this point, and this point is represent sigma. So D is higher, right? So this is sigma 1 at point D. So sigma 1 equal to actually distance OD, right? Distance OD. So what is distance OD? I can say OC plus OCD. I can say this one. OC plus CD. I can say this. Now, what is OC? Sigma average. Say OC equal to sigma X plus sigma Y divided by 2 plus CD. What is CD? Radius of circle. CD, radius of circle. That means this term. So I'm not writing this bigger term. I just say this is R. So this is sigma 1. And the point D coordinate will be what? Sigma 1, comma 0, because tau 0. That means line OD is the principal plane. And line FG is the maximum shear plane. Okay. So we got sigma 1. Now we need to figure out the sigma 2. So how we get the sigma 2? But the coordinate E is the sigma. How you can figure out sigma 2? You see sigma 2 equal to, this is sigma, that means OE, right? Sigma 2 equal to OE, this distance. And how I can figure out OE? If I take the OC, subtract E, subtract EC, then I get OC. And what is EC? Radius of the circle. So OC equal to how much? Right over here, sigma average. So this equal to sigma X plus sigma Y minus EC. EC is the radius of the circle. That means minus R. So this is my sigma. And obviously, coordinate of point E will be how much? Point E will be sigma 2, comma 0. Okay. Anyone has any question? Anyone? Hello? No question?
No, sir.
Okay. So we'll solve a problem, then it will be more clear to you. It's very easy. Now, what is left? Now, angle. You need to know where is the 2 phi S and where is the 2 phi B. So I erase all of the drawing. You see, what is our original line? Original line was line A, B. Right? Line A. Now, where is the principal plane? Our principal plane was, I take a little thicker line, this on our principal plane, line ED, because that plane shear stress 0. So how you have line AB, how you can go to the line D from A? Obviously, you have to rotate anti-clockwise from point A. So this mass angle, this angle is the 2 phi B. Because from point A, you can rotate point B. You can mention right over here too, that from point B, you rotate along this direction. But I will say better to start with we are concerned from this is the main point. So it starts with point A. From point A, if you walk down anti-clockwise, then you will get sigma 1. You get sigma 1, that's fine, because the other end will be sigma 2. Similarly, point A, it can turn, if you walk downward, point A coming to the point E, you get also principal stress, sigma 2. But why you will run too much? Try to use the shorter angle, shorter distance. So 2 phi p is the sigma, is principal plane. Now we need to figure out this magnitude, that how you can figure out this value. You look, if you know this distance, for example, if you use this triangle, this one, and this one, then you just apply tan theta. Tan equal to, that means this distance, then you need to out this one divided by this one. And from the geometry, you can easily figure out this distance and use tan inverse. You'll get 2 phi p. From 2 phi p, you got the phi p. And remember, how will you rotate? You rotate from line A to anti-clockwise. Now, how will you get the shear stress from point A? You see, from point A, you can go all the way upward to point F. Then your angle will be, this much angle will be 2 pi s. This much angle. But why you go that much? You see, if you go to the downward, easily you are getting the tau plane, a shear plane. Because if you rotate from point A to clockwise direction, you are getting G. What is the shear stress right over here? Equal to the radius of the circle. So that means this is minus R. So if you rotate clockwise, you are getting the shear plane. Now, how will you get the 2 phi s? Anyone? I will give you 2 extra marks in the class test. Who are able to tell me how I can get phi s, 2 phi s? You see, this angle is 90. Already we know 2 phi p. So phi s equal to 90 degree.
So both will be 45 degree.
No, might be not. It depends on value of tau x, y, sigma x, sigma y. But this angle is 90. So if you got phi p, you just say 90 minus 2 phi p is the tau s. Okay? Because this tau s, that means this value, this you use this triangle. With this triangle, you figure out the 2 phi p. And this is your shear angle. So you say 90 minus 2 phi p equal to shear angle. Okay? Now we'll solve a problem, then it will be very clear to you. Okay? So let's see how I can solve it. Is very better to solve it in the blackboard. Let's see. Let me open it. Okay, I took a Watt 5. At first, we'll see what is our coordinate system, our the x and y. So I'm sharing our main screen. We'll solve this problem with more circle. Okay. So what will be my coordinate of A? Coordinate of A, that means this point right over here. This will be A, comma, at plus sigma. Sigma tension or over here, tension. So it is positive, 90. comma, then I look for tau. How much tau? 40. Then I look for sine for tau. Is rotating which direction? Clockwise, right? So this tau will be right over here is negative. I'm sorry, positive, because more circle rotating clockwise is positive. So this point is 90, 40. Now I will figure out the point B. Point B, what is my sigma? 30 working upward. So 30, comma, what is my tau? Rotating anti-clockwise, right? So in the more circle, anti-clockwise tau is negative, so minus 40. So this is my coordinate. Now this coordinate we will draw in a graph. Then we figure out the all stresses. Okay, so let's see. I can so point A, my point A 90, 40, and point B is 30, 40. This, and I need to erase that one. One more thing, just 1 second. Let me bring that one. Okay, so did you see the screen?
Yes, sir.
Okay, so what I did, I just write down the coordinate and I bring the shear stress element. So make it a little bit bigger so you can see it. So this is a problem. Okay. Then what you'll do after you get the problem, over here it never says which one A, which one B, but it's better you can identify. So I always use this one A, this one I say B. You can switch, it don't matter, but better to start from this side. Okay, so this is my point A, this is my point B. Now I will start. You remember sign convention that if tau rotate clockwise, that will be positive in more circle. But in the algebraic method, it's opposite. If rotate anti-clockwise, then it's positive. Okay. Now we'll make the center of the circle and figure out the radius of the circle. So you see the radius of the circle, C, what is the coordinate or formula? Sigma x plus sigma y by 2, then comma. So what is coming over here? 90 and 30, 120 divided by 2. That means 60. 60, 0 is the center of the circle. Now we can figure out radius of the circle. So radius of the circle, what is our formula? Formula is sigma x minus sigma y divided by 2 whole square plus tau xy whole square. Okay, then you have root over. So this value sigma x is 90 minus 40, so 50. 50 by 2, that means 25, right? 25 square plus tau is 40 square. How much this value? Anyone can tell me? What will be the radius of circle? Anyone? Are you able to tell me that what will be the radius of the circle?
Sir, 47.16.
27 point,
Sir, 47.169.
47.169.
Yes, sir.
See, I am making a mistake or not. 90 minus 30. I think I'm making mistake over here. 90, 30, right? Okay, 90 minus 30, how much? 60, right?
Yes, sir.
90 minus, this is sigma x 90 minus sigma y. So 90 minus 30 is 60 divided by 2. So this will be, right over here, it will be 30. It will be 30 square. So if this is 30 square, then radius coming 50. Okay, this is the radius coming 50. So let me write down over here with my program. Not second. So I just write down the mass, the radius we got. Radius equal to 50 and location of center equal to, we got 60, 0. So this is our location of center. Okay. Now I can erase all the drawing. So at first you figure out the radius, you write down the formula. This is the formula, then by calculator you figure out. Then you figure out C equal to sigma x plus sigma y by 2, 0 equal to 60, 0. Now I have the 2 point. Have the point A, B. Now, how we can draw the circle? So obviously, you see, right now in our this problem, there is no minus sigma. So in the left side, we don't have that much thing. Everything will be in the right side. So cleverly, I can draw a x-axis, and vertical axis I'm drawing right over here because I know in the left side we don't have right. I can use draw in the middle, but cleverly I'm not drawing over here. Now you write down. This is 0. Now from here, you go in the left side. This is sigma, but this sigma is negative sigma. And right side, this sigma is positive sigma. And tau at the upward direction, tau if it's clockwise, then it is positive. And in the bottom is negative tau. I'd say this is minus tau. Okay. Now, you can locate the center, and you have radius with the compass. You can draw it easily. Then you can also figure out by scale, sigma 1, sigma 2. You can also figure out the radius. But it's better you first put all the point. At first, you try to point the point. You put point A. So at look that what is my point A? 90 plus 40. So 90 plus 40. From 0, you go 90 unit, right? Say you can write over here. I like to make it a bit smaller. So I'm saying I'm coming over here. Then you need to look in the tau. Tau is 40. So this is positive, right? So we need to go 40 this much. That means if I make a more point, so this is my point A. So I write down over here, this is my point A. And just say I'm saying this is my point B. Now, what will be the value of OB? OB will be how much? OB equal to sigma x. That means OB equal to 90. right? And what is value of AB? Value of AB equal to tau. That means this equal to 6. Now, so I put the point A. If you want, you can put point over here in the bracket. That is 90, 40. Now we will put point B. Point B 30. Says here right over here 30 and tau negative 40. So it might be right over here. So I am saying this is my point B. This is point B. You might mess up with this one. So I'm saying this is B prime. This is B prime. This is B prime. Now you join the line. This line, then this line. And immediately you mention this. What is this one? Say this one I'm saying F. So what will be the value of OF? OF equal to B x coordinate of B. That means that is 30. What will be BF? BF equal to y coordinate of point B. That means that equal to 40. That equal to 40. Okay. Now how will draw the circle? You just from here join to point. So this point will be your center. And you can easily figure out the center. You see what is the BF? What is this distance? B prime F. How I can figure out this distance? You see distance from here to here, how much? Sigma x. Distance from here to here, how much? Sigma y. So how much will be this? This distance. Sigma x minus sigma y. So this distance, this will be sigma x minus sigma y. Then if this is C, how much will be FC? Half of this one. That means it matches with our number. So find point C intersecting x-axis. Then you will solve your problem. You just now you need to make a circle. Okay. So I am erasing this line, this one, this line, erasing this one. Okay, now I'll make a circle. So when I make the circle, C is the center. So radius will be AC and radius will be BC. So if I make the circle, obviously it go like that. I might be not draw perfectly. It might be coming egg instead of a circle. I'm like, okay. Now, easily you can figure out the radius of the circle. Easily you can figure out. How? What is the AB? You can use the direct formula and you can figure out from here. What is AB? AB prime how much? 40. This is 40. And how much from here to here? I already told you that distance from here to here is sigma x plus sigma y. And this distance will be divided by 2. Or you can figure out this way. We know the OB, right? What is the OB? OB prime. OB prime equal to how much? X coordinate of point B, 90. Then you figure out OF. OF how much? X coordinate of point F. That means 30. 30. This is 90. So how much will be this one? B prime F. This will be how much? This will be 90 minus, this will be 90 minus 30. So BC will be then 60 by 2, then this will be 30. So by applying triangular formula, you get 40 square plus 30 square. So this will be 50. So now you got the radius. Now your problem is done. How? At first, you look to the x-axis. You see the circle intersect x-axis at this point and this point. So this value, if you say this is P, any letter you can say this is P, this is Q. You just figure out P coordinate and Q coordinate. Obviously, Y coordinate 0. So the x coordinate of point P is the principal stress sigma 1. So P, I can directly put number or you can put the coordinate. What is the coordinate? What is the OP? I can figure out. OP equal to, you see, CP plus OC. That means I can say if I add OC plus radius of the circle, I'll get OP, distance OP. So what is my radius? R, 50. And radius of circle, we got 50. Right? So we are getting now 100, should be 110. Okay, not 100. So CP is the radius of circle, we got 50. 50 plus OC. What is the OC? OC is sigma x. OC is the location of the center of the circle. Sigma x plus sigma y divided by 2. That means 90 plus 30 by 2 for 60. So ultimately OP is coming 110. So 110, 0. That means I can say from here the sigma 1 equal to 110 megapascal. Okay. Now, how I will figure out the sigma 2? Sigma 2 coordinate of point Q. You figure out the Q. How I can figure out the Q? I need distance OQ. So OQ equal to how much the OC? CQ, what is the value of CQ? You see CQ is the radius of a circle. So radius of circle is 50, right? 50 minus what is the we are heading in the wrong way. It is wrong way. We need to figure out the OQ. How we can figure out OQ? If I say OC minus CQ, then I get OQ. I need to figure out distance from here to here, right? So if I take the bigger distance from here to C and subtract this one, I'll get the OQ. So CO is the radius of the circle. I'm sorry, location of the center, 60, and CQ is the 50. So OQ ultimately is coming minus 10. Okay. So let me source the erasing all the line. Erasing all the line. So coordinate Q is coming minus 10, 0. That means I can say sigma 2 equal to minus 10 megapascal. Now, how we get the now? Yes, question.
Why are we taking minus 10?
Minus 10, yeah.
Sir, why? We know that.
Oh, no, no,
OC
minus 10. Yeah, right over here. What is the OC? OC is the 60, right?
60, sir. Yes, sir.
Plus 60
Minus
minus
50.
CQ is the 50, right?
Yes, sir.
So
Yes,
10.
sir.
My mistake. Should be 10. Yeah, good. Thank you. Now, how will get the tau? From the center line, you just draw a vertical line. From the center line of the circle, I'm drawing the vertical line. So this point will be 1 tau. This will be my 1 tau, and other tau will be at the bottom, right? Other tau will be right over here. So this distance, just I am saying, this is x and this is y. So what is the value of cy and cx? Cy and cx, radius of circle,
50.
50, right? So y
Yes.
coming minus 50, and why not x shear stress plus 50? And what is the x coordinate? Coordinate of the c, we got 60. So in the x coordinate, we are getting OC 60 plus 50. 50 is the shear coordinate. 50. At the y, we are getting 60 minus 50. So you will say tau 1. If you say this on tau 1 equal positive 50 and tau 2 equal to negative 50. Now, what is left? Angle. How will figure out the angle? So that is very easy. Let me erase all those things. All those things. I just need to figure out the angle. So you see, this is my original plane, point A. Okay.
Sir, your mic is actually mute, sir.
Okay, thank you. So this 2 phi p, because from point A, if you rotate clockwise, you will get principal stress sigma 1. So this angle is the principal plane angle. Now we'll figure out tan 2 phi p equal to A B prime divided by BC. So you have the angle. Now, how will get the shear stress? For shear stress, from point A, you can rotate all the way to point Y, but it's not wise. Always use the shorter distance. From point A, you just go all the way to point X. So this angle will be phi S. Okay, if 2 phi P, say coming, say 40 degree, 2 phi P, how much will be phi S then? 90 minus 40. So this will be then 50. You got did you got it? Because this angle is always 90, right? From here to here is always 90. So we got 2 phi p, just for example, after your calculation, 2 phi p, you got 40. So obviously 2 phi s will be 90 minus 2 phi. But that means it's coming 50. You don't need to calculate, you just figure out from the geometry. So far, any question? So far, anyone?
Sir,
Yes.
sir, why we aren't using tangent? Sir, we can easily find out using tangent.
Tangent to figure out what?
Sir, and the angle.
Who is tangent? For 2 phi S or 2 phi P?
Sir, for 2 phi p.
No, for angle, you need a triangle. Without triangle, how we can figure out the angle from the tangent? Line AB is going through the center of the circle. Okay, and this is the circle. You cannot take this one. You might think that, can I take this one like this one? No, this is not the triangular. You have to use a perpendicular triangle to figure out the angle. You figure out this distance, already we know from y coordinate of point A. We know this distance. We know the BC. So from here we figure out the tan 2 pi. Just you apply the tan, you get tan 2 pi. Okay.
Yes, sir.
And we know this angle is always 90. You see, from point A, if you try to rotate, you push down all the way y, you will get minus tau 1. But why will go that much? Why will work too much? From point A, you just go to point X, shorter distance. So you will get the tau 1 and positive tau 1. And that one, now you need the angle. How will get, you know, this angle is 90. So 90 minus principal plane angle, you'll get the shear stress. Now, within short, I'll show you that how we'll draw the orientation of the element. So our principal plane. So this is my original x-axis. This line, I draw it. This is representing my line A, AB. Okay, because along A represents along x-axis. Now, from the x-axis, if you rotate clockwise, then you get tan 2 phi. I'm saying sigma 1, right? Say you got 2 phi p equal to 40. So just for example, you got 40. What is the phi p then? 20 degree. This 20 degree you need to rotate clockwise direction. So I am rotating clockwise direction. This is my 20 degree. So I'm going to say this is 20 degree. Now, with this corner, I'll make a element, rectangular element. Rectangular element right over here. So you will have pencil and scale, you will draw better than me. So this is the center of the rectangle. So when I coming over here, what I getting? That means when I rotate 20 degree, I'm coming at point B. So point B, this is my sigma 1. Now what is the shear stress? 0. So obviously, what will add this end? With sigma 1. And over here, obviously, this sigma 2. Then you have sigma 2. And tau over here is 0, right? But if you want, you can still show it. You can say this is tau head to head and tail to tail. Then you can just show that over here I am showing tau, but this tau have no head. Then you say this is orientation of principal plane. Okay. Similarly, now how we can draw the orientation of the shear plane? Same way, but you look carefully. This is my original x-axis, but the shear plane, you have to go anti-clockwise. Right? You are going anti-clockwise. That means you are rotating along this direction. And how much will be this angle? 25. 2 phi p equal to 50, 2 phi s equal to 50. So phi s equal to 25. Now you make a triangular element. I'm sorry, rectangular element. Now you have to look carefully right over here. When you going clockwise, anti-clockwise, which point you came in? You came in at point X. So at point X, your shear stress. At point X, your shear stress is positive. Okay. Shear stress is positive. That means it's rotated clockwise direction. So that's why right over here you'll put clockwise direction. Because my mode circle, you got the positive shear. Now, you got one arrow, that will be enough to draw the your orientation. What will be the normal stress over here? The location of the circle, 60. So, or sigma average. So then you draw sigma average. Right over all the side will be sigma average. Sigma average. Now you draw other side of your shear. Always head to head, then tail to, I'm sorry, to this direction, tail to tail. Okay. So this is orientation of your shear. So very simple. But still, if you need help, let me know. I will try to, solve your problem if you have confusion. But any question? Anyone has any question? Hello? Anyone? And any question?
Yes, sir. No, sir.
No? Okay. One more thing. If you wait 5 minutes, I can finish the one little chapter. Or you like to wait until Monday? I think we can finish it, right?
Yes, sir.
Okay, just few minutes. One second. Okay, we'll talk about static life. Did you see the slide?
Yes, sir.
Yes, sir. We can.
Okay, this is very simple chapter, but always I put some question from here. That is called static life. What is the static life? For example, every day you wear shoe, right? And when you walk, then what happens? A shoe sole is compressed, right? And when you take your feet in upward direction, then there is no load on the shoe, in the sole of the shoe. So one time it is compressing, other time there is no load, it coming back to previous position. So that means one time it is shrinking, one time it is expanding. Due to that reason, over the year, it depends on how many times you wear the shoe or how many hours you are keeping shoe in your leg. So one time compressing, one time shrinking. If you walk like for 10 minutes, you are not able to make anything to your shoe. Still your shoe in good shape. But over the year, you see your shoe is damaging. That means in one time, it taking load. A simple load is working, very small amount of load, repeated time. But over the year, that means for 30 cycle or 50 cycle, it is getting damaged. So this kind of failure is called fatigue failure. So why fatigue failure comes? Say you take a wire, just aluminum wire. Then one time you do like that, you cannot break it. But you do 1,000 times like that, ultimately it will break. For example, if I take my cell phone and try to bend it, theoretically, I am applying load, so it will bend. Even you cannot see on my eye. But I do like that million of times, ultimately it will break down. Other example, you'll see in your water tap in your home, the water drop one by one in the floor, and gradually you see there is a small pit. You walk down through overbridge in Farmgate. Say they have a stair, in the stair they have a steel plate, and every time people walking on the steel plate and gradually material removed from there. So this kind of failure is called fatigue failure. Why it is happened? It is happened for small amount of load or stress. If it is worked repeatedly over a certain time, then that part will be failed. What I'm saying, you cannot make nothing for infinite life. Say you might say, okay, I'm developing a car that will go for ever. No, everything has a certain life cycle. For example, your connecting rod of your piston. So when piston going upward is pushing. That means it's getting compressive load, like a column. So one time is getting compressive load, other time is getting tension load. So one time tension, one time compression. So what happened? The same thing, like you take wire, one time do like that. So ultimately over some year it is failed. Other example, say a ship taking crude oil or taking some goods from China and going to the Alaska. So in China, temperature like our country, 30 degrees. In Alaska, might be minus 30. So when a ship going from China to Alaska, then what will happen? It will shrink due to decreasing temperature. But visually, we will not able to realize. But all the joint, all the material, it will shrink. Okay, so he unloaded some goods in the Alaska, stay for 15 days. So whole 15 days he will be shrink. Then he loaded the ship, he come back to China again. He come back to China, again warmer temperature, all the material will again expand. So a ship is designed for 30 years or 15 years. Why we don't design for 90 years, 100 years? If we do like that, maintenance cost will be extremely high. So during design, I have to think that that ship, how many times it will be shrink and how many times it will be expand. Based on that, we have to figure out the life of the ship. So question from here might be, what do you mean by fatigue failure? Fatigue failure is a failure due to the cyclic stress that work repeatedly over a time on a parts. That is called fatigue failure. Now, how fatigue failure deteriorate? Sometimes you say you like to buy a piston, you like to buy a cylinder. You will see the surface is smooth. Why keeping smooth? Normally, even you buy a simple thing, you'll see all the sharp edges, they use the fillet. Because, and other thing, why material fail? Material fail because inherently there might be some defect, there might be some crack. You make by casting, there might be some void. You use alloy material, that material might be not mixing homogeneously. So that's why gradually it developed a crack, and over the year it failed. And also temperature is also make big difference. I give you a nice experience. I bring a shoe from US, and over the time, almost a year, I put in the shell. Okay, and one time I put on that shoe. So I just walk down from the 6th floor to ground floor. Then I feeling there's something wrong with my shoe. Okay. Then I look at the shoe. I see all the rubber is fall down. Why? Because due to the weather, due to the temperature, due to the humidity, the stiffness of the rubber is gone. So even a parts you keep on the shelf without using, but still it has a certain life. This is called shelf life. And some company shelf life say 3 months, they'll say reject it. Even it is good, they'll say reject it. Okay. So fatigue life, there is some factor that affect the fatigue life. Number one thing, that temperature, that I already give you a example. So you just remember those factors, temperature. Then surface quality, if surface has a rough surface, too many sharp edges, crack developed from there. Then oxidation, that means, or corrosion, say keeping in the atmosphere. So you have some rust from there, your fatigue life will be decreased. Then there is a grain size, but forget about the grain size, that one is from the metallurgy, you don't need to know that much. Then internal defect, say there is a micro crack, there is some air bubble inside the material. You use alloy material, but they don't mix homogeneously throughout the parts. Then it will crack. If you don't mix homogeneously, there's somewhere material mix properly, other don't mix improperly, then what will happen? Their crack will be developed from there. Other thing, residual stress and cyclic stress. Residual, what is residual stress? You might heard this name. That means stress in the parts without load. There is no load, but there is a stress. For example, you see in the construction, they use the steel rod, and you see they bend it at the end, but they say there you see there is a corrosion. Because the steel rod, you bend it, he is feeling load because he's trying to go back in previous position, but he cannot do it, go back. But externally there is no load. So that kind of situation is called residual stress. For example, you make a gas cylinder. You take aluminum sheet or steel sheet, bend it, then weld it. But after bending, you need to make sure that material will not try to go back in previous position. If he try to go back in previous position, that means he will generate some stress inside. So after you bend the sheet, then you have to do some heat treatment. It's called annealing. That means you have to make it stress-free. You make it stress-free, then you put your product, then there will be no stress inside. By mistake, say you are working in LPG pump, in gas cylinder manufacturing unit, and your heat treatment you don't did clearly. And your mechanics will say, go ahead, we can release this product. But what happened? Inherently, life will be reduced. It might be those 10 years, you design for 10 years, but after 6 years, it might be exploded. Okay. So question from here, what do you mean by static life? What are the factors influence on static life? Okay. So this much from this course. Actually, we don't have that much time to discuss more. So any question? Do you have anyone has any question about the